Define atomic mass and use your definition to explain why the atomic masses of the elements are not integers or whole numbers. Okay, so how come the atomic mass isn't like 1 or 2 or 3? Why is it, 1.008 or something like that? Okay. Well, the atomic mass that we're used to is, or the ones that we see in the periodic tables, is the weighted average. So, and the weighted average in proportion of the natural abundance. Okay, so for instance, it's the weighted average weighted by the proportion of the isotope in the natural environment. And it's of the various mass numbers of the various isotopes of an element. Okay, so this is a lot of confusing words here, but I'll try and unpack it for you. Let's take carbon. Carbon can exist in various forms called isotopes. And these isotopes have different numbers of neutrons. So one isotope may have 6 neutrons, the other one might have 7, 8, 9, etc. Okay? So they have different numbers of neutrons, but they don't occur in the same proportion. The carbon with the mass number of 12 is the most common. And then the other ones, like carbon 14 or carbon 13, carbon 11, are much less common. So when you take the average weighted among how frequently they occur in nature, you'll see that the carbon 12 dominates the average. So the average atomic mass is close to 12. These extra heavy isotopes that we have, like 13 and 14, skew the average just slightly. So that's why it's 12.01, because there's just enough of these extra isotopes to throw off the average slightly towards a number higher than 12. So the atomic mass is simply just a weighted average. It's just the average based on how frequently each isotope occurs in nature. And because it's a weighted average, it's not going to be an integer, because averages rarely turn out into integers unless the average itself can whittle down into an integer. So it's not likely that a weighted average will ever be an integer anyway. That's why, because you have all these different isotopes, and if you take the average mass of each of these isotopes based on how frequently they occur, or the proportion of times they occur, then you'll see that the average will be skewed slightly, and that's the atomic weight or atomic mass that we're used to. So it's quite a complex situation, but as you get to know isotopes a little bit better, you'll start to see why this is actually not so hard to understand.